Cole has done a great job of talking about the deer project and some of the final stages of the analysis we've been getting out of there. He mentioned that we have quite a bit of, I guess you'd call bycatch out of this camera array. I think that demeans the value of the data that we actually get, calling it just incidental bycatch. In effect, these cameras were put up for the purpose of deer, but we got everything else in the boreal forest on these cameras, and so we recognized we had a great opportunity to capitalize upon some fairly heavy investment on the front end. So we suggested, let's take this data, and let's take a look at all the non-deer species and understand, or try to understand a little something about the responses of other mammals in the Northeast Boreal Forest to anthropogenic and natural land cover. So PTAC, EUPRF generously funded some of that exploration. I'm going to talk to you about that today, focusing on moose and predators for all the obvious reasons that we've talked about already. More deer, perhaps more moose, means more wolves, means less caribou. So everybody's familiar with that one. The hypothesis, the working hypothesis here is that anthropogenic footprint may be increasing prey populations of that Northeast Boreal Forest. You're knocking down a lot of mature forest that most things can't eat, and you're putting in a lot of early cereal vegetation that most things really benefit heavily from. So when you've got increased in the herbivore populations, you get an increase in the carnivores, and this might be pervasive throughout the Northeast Boreal. And as I said, this project was originally developed to examine this hypothesis for white-tailed deer, and based on our work over the last couple of years, we found very compelling evidence, I think, that basically this resource subsidy that we're unintentionally creating is inflating white-tailed deer populations, and more importantly, making them stable across those weather events that we would expect to knock those populations down in. But deer, as I said, are not the only player in this system, and I think it's a little bit narrow to focus solely on that particular species. There's lots of other players that will have an effect on caribou and, importantly, have an effect on each other. So let's go take a look and see what those might be. There's obviously moose. So moose eat early cereal vegetation. They're browsers. Is Terry still here? Terry could tell you that moose do some really crazy things sometimes. So we might expect moose to increase with all this increased early cereal veg in the landscape, but we might expect some opposite responses. I can tell you as the former moose manager for Newfoundland, they're kind of hard to predict, but they sure are cute. There's black bears in this system. I think it's short-sighted to discount the importance of black bear predation, especially on caribou neonates, but also on other prey items in this system, things like deer and like moose. Black bears are also very hard to predict because they're omnivores. They're not nearly as nice as wolves, in that more animals means more wolves. Black bears operate in that gray nebulous omnivorous range where they can respond favorably to early cereal vegetation or favorably to increased prey populations, or perhaps negatively to anthropogenic footprint because of human activity, which humans being one of their only predators in the system. They're also cute. These guys are doing a tango in the corner. There's lynx, of course. So lynx are a player in the system. We don't really know how they operate as regards to caribou, but we know that they do feed upon the other prey species in here. So we should consider them as a competitor in this multi-predator system. And then there's other things. There's mesocarnivores such as fishers here. That fishers are sensitive species in Alberta, expected to have some response to anthropogenic disturbance, a negative response. That's why they're considered a sensitive species. They're carnivore, but they're also a scavenger, and so they might enter into this equation as a competitor at some level. But just as a whole, our working hypothesis off the bat here is how do these anthropogenic features across the Northeast Boreal affect the mammal community as a whole? Can we find some consistent trends here? Is it that we see these species are all going up, these ones are all going down? Can we identify specific anthropogenic features that we can put the the weight of evidence on, point the finger of blame and say, I think these are the things we need to think about reclaiming here. Is that actually seismic lines, or is that some of the other components of oil and gas extraction in this landscape, right? That would force us to maybe take off some of the seismic line blinders and broaden our nets. Not that we need some more bad news, but you know what? All information is good information. So this project just started recently, so I would love to be up here and telling you about the results of this thing, but we've only been working on it for a month and a half. So I'm going to give you a brief progress update of where we are so far, hopefully as a little teaser that we can provide some better information down the road. So our research questions: is the relative abundance of moose, bears, and other species significantly affected by anthropogenic footprint? And if so, which of these landscape features have the greatest effects on each of these mammal species? So Cole's already told you about our camera array. Spans about 3,000 square kilometers in the northeast, running from the air weapons range north towards Bond Lakes. We deployed 62 Reconyx cameras out there. We used a stratified random design based on AVI data and access, and I've talked about that in previous years. We ran these cameras for 3 years continuously, October, November 2011 to 2014. So it presents this really neat and quite unique 3-year contiguous data set across the Northeast Boreal Forest. So I was planning a summary slide showing all the different detections of different mammals, but I didn't get to that point yet. But basically I can tell you what we did is we summed the number of occurrences of each of these species at each point. And then we lumped them up further. So our response metric here that I'm going to talk about today is the number of months that each species occurred at each point in space. Relative abundance is kind of a sticky wicket, right? It's not true abundance. You got to do a whole lot of extra work to try to translate between relative and true abundance, as Cole described. And there's a bunch of different definitions of relative abundance that we could use, and we plan on looking at 3 or 4 of them to look at concordance among these different metrics. But today we're looking at basically the ability of a species to persist at a site. And I'm talking about 2 years worth of data today because that's all we had time for before this meeting showed up. So we have a response metric, the persistence of each species at each camera site for a 2-year period. And then around each of these camera sites, we quantified the landscape around each site in a 1 kilometer squared area. So we used 3 GIS layers, principally. The first is the ABMI human footprint layer that's publicly available. That was updated to 2010. We knew that there was all kinds of linear features in the landscape that are not represented in that data set, and so in a collaboration with Alberta ABMI, they provided us with a linear features layer contemporary to 2012 based on a bunch of updated imagery that they had received. So this map here, the width of the lines are obviously not to scale, but it gives you some sense of the degree of anthropogenic disturbance in that landscape. So there's Winifred Lake right there, and then Christina in the middle. The dark rusty brown things are 3D seismic, laid out in a hashtag pattern. They've all merged together because of the width of the lines. And then there's lots of the traditional cut lines in that landscape. There's lots of roads, there's lots of well sites, there's forest harvesting towards the north. It's a pretty active landscape. If you're going to call it a working landscape, this is a very hard working landscape. And then, of course, we have AVI, enhanced AVI data that we were given by Alberta Environment and Parks. And so we quantified both natural land cover and anthropogenic features around each site. And then we related one to the other using generalized linear models, which related species months, or the persistence of the species in that 2-year period, to footprint, human footprint, updated linear features, and AVI. And there's between 5 to 15 different variables in each of these categories. So we ended up with a general linear model, basically a regression between the species and all these different features for for each species that we looked at. We then used, I'll spare you some of the stats, but we then used a step AIC function, which is basically like a stepwise regression model. And what that does, it basically picks out the best and most parsimonious model out of all of these different variables that describes the features that predict the species occurrence. So you're taking all these different variables from all these different things and you're distilling it down to the smallest possible set of landscape features that explain the persistence of that animal. And then so we then reported those variables for each species. So some of the results so far, I found them somewhat surprising because I didn't necessarily think that anthropogenic features were going to factor into every single species that we detected on that boreal landscape, but in fact they did. So this graph here, going up the left, is the number of species for which the feature was significant, and it's based on 6 different species that we've run so far, as I said, work in progress. And along the bottom, there's all the different possible variables that result from the final models. So on the left are all the natural features, the ones in green, so upland deciduous, mixed wood, tamarack, and open wetland and such. On the right, in the red, are all the anthropogenic features, so cut blocks, seismic density, pipelines, well sites, roads, and trails. So for every single species, at least one, and usually, well, in some cases, every single anthropogenic feature variable was significant in those models. Meaning that for every species we looked at, anthropogenic features played a significant role in predicting their relative abundance and distribution in that landscape. So indicating to us that we're focusing quite a bit on caribou and wolves here, but there's a suite of other players that are also being affected, significantly affected, and we just don't know what that end result is going to be for caribou or for the mammal community in general. So we should probably take a look. One of the things we can do out of these models is look at the effect size. So in terms of a regression analysis, right, just your standard X and Y, and you could draw a slope. If you've got a steep slope, that's a high effect size. If you've got a shallow slope, that's a very low effect size, right? So you can really jack up seismic line density. If you've got a low effect size, that really doesn't change the response in your animal much. Whereas you've got a really steep slope, a small change in that seismic line density will have a huge impact on that species' persistence. And what we found is that the effect size of anthropogenic features dwarfed all the other variables in that model. So again, on the left we have all the natural features, deciduous through to open wetland, and then beyond that we have cut blocks, seismic density, and such. So you can see the effect size here, represented by the height of the bars, is really large. So I'll note that some of these effects are positive. Some of these species are responding very positively to anthropogenic features. Some of them are responding very negatively to anthropogenic features. So everything above the line is a positive response by a species. Everything below is a negative response by a species. So you can see that roads and trails are having a very, very large effect. So big effect size roads and trails. You put a small amount of roads and trails in, you get a big response by those species in the boreal forest. Well sites also has a pretty significant effect size, as does pipelines. So this allows us to parse out some of those differential effects across the community. And you'll notice here that in this first cut anyway, that seismic line density, it has some effect size here, but it's not the big player in the system. Certainly, I think we have great evidence that it really is for wolves and caribou. It's a really big deal, but for the other species in the system, perhaps not so much. I'll talk about, I'll highlight one species in particular, and that's moose. So based on my experience with moose, and certainly I think based on the existing literature, we expected a very positive response by moose to anthropogenic footprint in this landscape because we're giving them lots of good things to eat. But that's not what we found. So moose up here, this is the graph of moose response to well sites in that landscape. So with increasing well sites, we saw a decrease in relative abundance of moose. With an increase in regenerating areas, which is sort of a catch-all term for a bunch of stuff that's old forest knocked down that's now young forest, there's a negative response. And to roads, there's a marked negative response. As you increase the amount of roads in that landscape, less and less moose. So based on this preliminary analysis, and I keep saying that word so you remember it, it looks like that moose are responding negatively to anthropogenic footprint in this landscape and not positively as we'd expect. Now, is that because of the influence of wolves with the jacked up wolf numbers that moose are now taking a kicking? We're not really sure, but this first cut, and this is all this is first cut is a step back and saying, what's happening with all these different species in this landscape? What other things do we need to be aware of, such that when we try to make some conclusions about the effects of anthropogenic activity on caribou and wolves, we actually make sure we get it right, and there's not some unknown thing coming in from the side that's going to screw up all of our conclusions for us. So the next steps, we are producing new analyses based on fully updated species data over a 3-year period. We're trying a bunch of different model configurations with lots of validation. So you've heard, I think Shane mentioned it, and Dallas and others, that we can't just produce models and say, there's our best. We want to do a lot of scientific honesty and validate these models and say, here's the conditions, or here's the range of comfort we have here, and here's how certain we are about these results. And so we're going through that process as well. We're going to produce some single species models for moose, bears, wolves, and all the other species. And we're going to look at 2 different metrics. The one I talked about here, the persistence at a site through time, but also relative abundance, basically the raw number of camera detections, number of independent observations at that site, to look at concordance between them. So whenever we're finally done this, in a few months' time, we should have something that we're very, very confident with, that we can present to decision makers and say, these are the features that are affecting the broad spread of mammals in this place. Let's talk about what might be causing it and what could be done about it. We're also examining trends in species response to try to see if there's similarities among different species. And ultimately, we think this is a first key step in really understanding those cumulative effects on the whole mammal community as a whole, which ultimately interact with one another. And we're expected to have some profound effects ultimately on woodland caribou and the functioning of the functioning of the landscape as a whole. So with that, I'd like to say thank you very much to all of our funders, GOA, AITF, and then of course to PTAC and Meg Energy.